Welcome back, guys. Today we're going to be looking at topic 6.2, solving triangle problems. Now, this is a continuation of what we did in our last lesson, where we looked at trig ratios and how to solve triangles. Today's lesson is broken into two videos. In the first video, we're going to be looking at word problems and practicing how to draw the diagrams for those word problems. We're also going to look at some diagrams and talk about word problems that I could ask based on the diagram. And then in the second video, we're actually going to go through and solve all of those problems. Now, for this first video, I'd like you to treat it like an interactive video as much as possible. I have a screen where I've got some pull tabs. As I pull out a tab, there's going to be a word problem on there, and I want you to pause the video and try drawing the diagram yourself first, and then unpause, check your answer, and we'll move on to the next one. That's the best way for you to identify how much of it you already know on your own. All right, so moving on right away, I'm going to pull out some tabs here with word problems, and I just want you to practice drawing what you think the diagram would look like. Now, when I reveal my diagrams, I've used some clip art to make the picture look a little fancier, but ultimately all you need to draw is the triangle piece. So the first question here says, a ladder is placed against a wall, forming an angle of 63 degrees with the ground. If the foot of the ladder is 3.7 feet away from the wall, how long is the ladder? So you're just going to draw a triangle diagram. You're going to label where the 63 degrees is between the ladder and the ground. You're going to label where the distance between the foot of the ladder and the house is 3.7 feet. And you're going to label the unknown. So our unknown in this case is how long is the ladder. All right, so pause the video, try drawing the diagram, and then come back and check your answer. All right, now once again, as I draw my diagrams, I've used some clip art just because I've got the computer here and I make it look a little fancier. But when you're drawing your diagrams, ultimately, I don't care about the house or how fancy your house is or even that you draw a house. I just want to see this triangle. And so you would have drawn a triangle here that showed that the angle between the ground and the ladder was 63 degrees. And you would have shown that the distance between the ladder and the house was 3.7 feet, and the length of the ladder as our unknown is x. So we always want to label what we know and what we're looking for. Now you may have drawn your triangle in a different direction. You may have drawn it this way here and had the 63 degrees here, the x here, and the 3.7 feet here, and that's fine. Just make sure that you've labeled your units as well as your unknown. All right, so we'll erase these here and we'll move on to the next question. All right, so the next question says that a tree casts a shadow that is 13.5 meters long and the angle of elevation to the sun is 43 degrees. How tall is the tree? All right, pause the video, try drawing your picture, and then come back and check your answer. All right, now often when we're doing these questions in class, I actually do this as an activity in class. So we've got the whiteboards out and we're drawing pictures and flashing up our pictures. The most common challenge with this question is always, where is the shadow? Where do I label the shadow? And the question I'll often ask students is, well, where does a shadow occur? Does it show up high at an angle, or is it up and down, or does it occur on the ground? And the shadow, our shadows are on the ground. So the length of the shadow would be right here, 13.5 meters. And the angle of elevation to the sun, if you remember, if we're looking at angle of elevation, that's us elevating our eyes from the horizontal. So the angle of elevation to the sun is looking up from the horizontal is 43 degrees. And then our unknown is, how tall is the tree? All right, moving on to the next one. The question says you have a rectangular piece of sheet metal that measures 8 feet by 4 feet, from which you need to cut 2 equal right triangles. What angle from the horizontal will you need to measure to make the cut? All right, so pause the video, try drawing your diagram. Now, for this particular diagram, yours may look different than mine because you may have oriented your sheet metal differently. And so for this question here, I've chosen to draw the 8 on the as my length and the 4 as my width. And so for this particular diagram, it says that we want to cut our sheet metal in half to make two equal triangles. So that's our diagonal. And the question is, what angle from the horizontal do we need to cut? So that would be right here. If you chose to orient your sheet metal differently, let's say that you decided to make this 4 feet and 8 feet, there would be our uh, diagonal, and this here would be our x value. So it just depends on which way you've oriented your sheet metal as to what your diagram would look like. All right, moving on to the next one. So this question here says a cell phone tower is supported by two guy wires, each attached to the ground 3 meters from the base of the tower. The angles of elevation for each guy wire are 46 degrees and 34 degrees. How much higher up the cell phone tower is the top guy wire attached? Now the question I often get is, what is a guy wire? Those are just your support wires. So we have these supporting wires that are supporting the cell phone tower. So again, the cell phone tower is being supported by two guy wires. They're attached to the ground 3 meters from the base, and the angles of elevation for each guy wire are 46 and 34. And the question is the difference in the heights between those two guy wires. So again, I'll give you some time to pause the video and try drawing this diagram. All right, coming back here, these ones are often a little trickier because we actually have two triangles. Now, this diagram and the next diagram that I have here, these are not questions that I'm going to be solving in the next video. This is actually going to be a lesson that we get into in a couple days here where we look at two triangle problems. And so for this particular question here, we have the cell phone tower being supported by two guy wires. So those are our diagonal blue lines. And each of those guy wires is 3 meters from the base. So this here would be 3 meters, and this here would be 3 meters. And the angles of elevation for each guy wire are 46 degrees and 34 degrees. Now, if you chose to have your triangles on the opposite sides, it would just be a mirror image of what I have. Notice that the longer guy wire had the bigger angle of elevation, because if we're moving up the pole, the elevation is going to get higher as we go higher up the pole. And the angle of elevation here is 34 degrees. And the question is, how much higher up the cell phone tower is the top wire attached? So we're looking for here. So ultimately, to solve a question like this, we're going to have to find out how high up the pole one of the wires is, how high up the pole the other wire is, and then find our difference. And again, we're not going to solve these problems in today's lesson, in the other lesson video, because these involve two triangles, and we'll get into those in another lesson. All right, taking a look at our next one here. So from the top of a 350-meter tall building, the angle of elevation to the top of another building is 60 degrees, and the angle of depression to the bottom of the second building is 35 degrees. And the question is, how tall is the second building? When we get into our multi-triangle problems, this is one of the most common questions that you will see. So again, I'll ask you to pause the video and try drawing the diagram. All right, coming back here. We'll erase the diagram. So, interpreting the problem here, we have a 350-meter tall building. So that's our 350-meter tall building right there. And the angle of elevation to the top of another building is 60 degrees. So I actually have these reversed, so I need to fix those. 60 degrees, the angle of elevation, and the angle of depression to the other building is 35 degrees. So I had my angles mixed up, so I fixed that here. So the angle of elevation to the top of the second building is 60 degrees, and the angle of depression to the bottom of that building is 35 degrees. And the question is, how tall is the building? So in a question like this, when we get into solving these later, ultimately what we're going to have to do is figure out each of these two heights, but we're going to have to use the information we have to find that out. But we're going to need to know how tall the two heights are. We already know this one is 350. We're going to have to figure out this missing height here so that we can find out the total height of the building. And again, we'll get into that in another lesson. So those are just some practice questions with drawing diagrams. We're now going to take a look at some diagrams that are already drawn, and I'm going to ask you what kinds of word problems I might ask. So here's a question. I've got some of it already a little bit revealed here, so we'll color that in. All right, so the first question here, it says, or the first diagram here, we have a picture of a river. We have an angle of 31 degrees and 400 meters. So the question that I could ask might be the width of the river. So I might ask you the width of the river. If I had my X in the other spot, or sorry, other questions I might ask if I had moved my X to a different spot. If I had asked you this question here, sorry, let's change the pen. If I had put my X value right here, I could be asking you for the angle from the vertical. I probably wouldn't ask you that though, because I've already given you the angle here. So most common question that I would ask in this situation would be, what is the width of the river? Now, the way that that word problem might be worded would be this. So a possible word problem could be that a surveyor sets up a surveyor post directly across the river from a landmark. He then heads downstream for a distance of 400 meters. He takes a sighting on the tree from downstream, and the sighting angle is 31 degrees. Using this information, what is the width of the river? All right, so ultimately the diagram is just asking you for the width of the river, but the word problem's a little bit longer. So often when we have trig problems like this, the word problems can get a little bit wordy and a little bit confusing, but if the diagram is given to you, use the diagram as your guideline. All right, let's take a look at another example. So here we have an airplane, and we've got 12 degrees as our angle of elevation, and we have an X. So again, ask yourself, what kind of question might I be asking? And here's the word problem that went along with this diagram. So a plane is climbing at an angle of 12 degrees for 6.2 kilometers. Notice the plane is traveling for 6.2 kilometers in that diagonal direction. How far does the plane travel horizontally? If I had moved the X to here, another question I could ask you is, how high above the ground is the jet? Okay. After it's climbed that 6.2 kilometers. So depending on where the diagram is, it would change what I was asking you for. All right, next question. We've got a skier going downhill. So again, take a look at the diagram and ask yourself, what am I asking you for, and what might that word problem look like? All right, so the word problem that went with this question, a downhill skier is transversing a steep slope. If this section of the 1,420 meter ski slope has a vertical drop of 950 meters, what is the angle of elevation to the slope? All right, let's take a look at a couple more questions here. Now, this one gets a little bit trickier. Again, these are the two triangle problems, but I have 32 degrees, 42 degrees, and I'm going to draw in an X right here. What might I be looking for in this diagram? So if you thought, yes, I'm looking for the height of the antenna, that would be the case. The word problem would give me all of the information about these angles of elevation and how far away I'm standing from the tower. So for this question here, it says a person is standing 275 feet from the base of a building. The angle of elevation to the base of the tower's antenna is 32 degrees. And it says the angle of elevation to the top of the antenna is 42 degrees. And the question is, how tall is the antenna? So we're going to have to figure out some different measurements here so that ultimately we can figure out the height or the height of the antenna. Now again, we're not going to get into the solving of these, just what the diagram means and how the diagram relates to the word problem. All right, taking a look at example number 5. Ask yourself what question I might ask here. All right, so if you notice we've got a baseball player, we know that the distance from the pitcher's mound is 6 foot 6 inches, or 6.5 feet, and the distance to first base is 90 feet. So, question I might be asking. Again, the first part of the word problem gives us the information that we know already. So the distance from the pitcher's plate or the pitcher's mound to so from home plate to the pitcher's mound is 6.5 feet, and the distance from home plate to first base is 90. It should say 90 feet, not 90 inches. At what angle from the pitcher's mound would a player need to run to get onto first base? So we're looking at the missing angle here. All right, and example number 6. What might I ask you for this question? Notice there's no unknowns, so think about what possible unknowns I could have and what I might be asking. All right, now if I put my unknown here, I'd be asking for the length of that section of the roof, okay? But in this particular question, I'm actually going to be giving you the unknown that you're going to have to find. The unknown that you're going to have to find will have to be here, and we'll go into that once I reveal the word problem. So in this particular question, it says, given the dimensions in the diagram, what is the pitch of the roof? Now, pitch is the same as slope. So in this one here, I haven't labeled my unknown, but I'm told that I need to know the pitch of the roof, pitch being slope. And if you remember from a previous unit, slope is rise over run. So in order to do that kind of question, I need to know my rise. So I would actually have to find the rise of the roof, and then rise over run would give me my slope, which is also my pitch. Now, one more question here. I'm going to have one more diagram question, and we've got that one right here. So it says you're in a hot air balloon that is floating 500 meters above Eagle Butte High School. At what angle of depression would you be looking if you were looking at a point on the ground that is 800 meters horizontally from the balloon? Again, take a minute to pause the video and draw the diagram. All right, so again, you don't have to have the fancy air balloon. My diagrams certainly don't look this fancy when I'm drawing them. But for this first question here, I have my hot air balloon, and it is 500 meters above the ground. And I know that my horizontal distance is 800 meters. I'm looking for angle of depression. Now, sometimes when I'm drawing this diagram, it'll look a little bit more like this. So got my little hot air balloon, and my vertical distance is 500, because I'm often thinking about my vertical distance as right below the balloon. Or I could have taken and moved that line over. Just move these over a little bit. No, I'll just draw it there. Okay, I'll erase. All right, so I'm just going to draw my line over a little bit, right below the balloon. And so I'd picture this as being the 500 meters. And then I know that my distance here is 800 meters away. And I'm looking for angle of depression. So angle of depression is actually the distance from, or the angle from the horizontal. So this would be my angle of depression. And if you remember from our previous video or our previous lesson, angle of elevation is also, or angle of depression is also angle of elevation. So my angle of depression is looking down from the horizontal. My angle of elevation is looking up from the horizontal, but it makes that Z, so these are equal. So either one of these diagrams is accurate, and so I can be calculating my angle of depression here. I can also be calculating my angle of elevation here. But if the question is asking you for angle of depression, if this was a test question and I was asking you for angle of depression, I would be wanting to see that you were able to clearly understand where the angle of depression is. So even if you are calculating angle of elevation, I want to see that you know that this here is the angle of depression. So however you draw your diagram, I want to see that you clearly know what angle of depression is. All right, guys, so these are just some of the word problems that you could come across, and I just wanted to give you a chance to practice drawing the diagrams before we get into the solving. All right, so when we get into part 2, we'll be looking at how to solve a number of these problems. Thanks, guys. See you soon.